You know what a quadratic equation is, and you are also familiar with the two methods used to find its solution or roots, the factorization method and the method of completing the square. In the factorization method, the middle term of the quadratic equation is split into two linear factors. Further, on equating the two factors to zero, the roots of the quadratic equation are obtained. In the method of completing the squares, the quadratic polynomial is written as the sum of a constant and the whole square of a linear expression in x multiplied by a constant. Then, the roots of the quadratic equation are obtained by taking the square roots. Now, let's apply the method of completing the square in the general quadratic equation. To proceed, let's consider a general form of quadratic equation ax squared plus bx plus c equals to 0. Let's call this equation as 1. Now, divide equation 1 by a as shown to get an equation x squared plus b by ax plus c by a equals to 0. Call this equation as 2. Now, to complete the square, rewrite the middle term as twice b by 2a into x. Then, add and subtract b by 2a whole squared to get equation x plus b by 2a whole squared equal to b squared minus 4ac whole upon 4a squared. Let's call this equation 3. If b squared minus 4ac is non-negative, that is, greater than or equal to 0, then its square root is a real number, and we get two roots alpha and beta of the quadratic equation as shown. In fact, equation 4 is called the quadratic formula. We use this formula to find the roots of the quadratic equation. The expression b squared minus 4ac is called the discriminant and is denoted by d. Let's now apply the quadratic formula to find the roots of this quadratic equation. The given quadratic equation is of the form ax squared plus bx plus c equals to 0. Therefore, in the given quadratic equation, a is equal to 2, b is equal to minus 7, and c is equal to 3. Now, compute discriminant d using b squared minus 4ac. Substitute the values in the quadratic formula and simplify to get the roots of the quadratic equation as 3 and 1 by 2. Let's now solve some problems using the quadratic formula. Solve the given equation using the quadratic formula. Comparing the given equation to a general quadratic equation ax squared plus bx plus c equals to 0, the value of a, b, and c can be written as shown. Now, compute the discriminant d equal to b squared minus 4ac. The discriminant, being the whole square of a quantity, is non-negative. Using the quadratic formula, the roots of the given quadratic equation are calculated. You thus know how to find the real roots of a quadratic equation whose discriminant is greater than or equal to 0. But what if the discriminant d of a quadratic equation is less than 0? In fact, the discriminant, as the name suggests, helps us decide the nature of the roots of a quadratic equation. Let's see how. Consider three quadratic equations. In the first equation, the discriminant is greater than 0. Hence, by applying quadratic formula, we get real roots of the given first quadratic equation. Let's consider the second quadratic equation. It has the discriminant equal to 0. Now, using the quadratic formula, we get two equal roots of the quadratic equation. And now, consider the third quadratic equation. It has the discriminant less than 0. As a result, the quadratic equation does not have real roots, as there exists no real number whose square is a negative number. The following observation can be summarized as: when the discriminant in the quadratic equation is greater than 0, then the roots are real and distinct. They can be obtained using the quadratic formula, and if the discriminant is equal to 0, then the two roots are equal. In other words, the quadratic equation has a repeated root minus b upon 2a. This root is by putting d equal to 0 in the quadratic formula again. However, if the discriminant is less than 0, then the quadratic equation does not have real roots, as the square root of a negative number is not real. Find the nature of the roots of the given quadratic equation. The given quadratic equation is of the form ax squared plus bx plus c equals to 0. Therefore, in the given quadratic equation, a is equal to 4, b is equal to minus 5, and c is equal to 3. Now, compute discriminant d using b squared minus 4ac. Observe that the value of the discriminant is less than 0. Hence, the given quadratic equation has no real roots. A factory kept increasing its output by the same percentage every year. Find the percentage if it is known that the output of the factory is doubled in the last 2 years. Let the initial production 2 years ago be P, and let the increase in product every year be X%. We use the formula to calculate the amount in the case of compound interest to evaluate the production at the end of the second year. As per the given condition, the production has doubled in the last 2 years. Therefore, 1 plus x by 100 whole squared is equal to 2. Let's call this equation 2. On simplifying equation 2, we get quadratic equation in x. Using quadratic formula, the roots of the equation are calculated. As the initial output cannot be negative, we ignore the negative root of the equation.